All right, number one on our practice test or our chapter 2 review. Determine whether the statement is true or false. You've seen something like this in the past. If it's false, give an example to show that it's false. If the limit as x approaches 6 of f of x is equal to 36, then f of 6 is equal to 36. So as I'm getting close to 6, I'm getting close to 36. That does not mean that I actually reach 36. So this statement would be false. And you can show that a couple of different ways. You can show that just with a picture of some graph, and it doesn't matter what the graph is, as long as you show me that here's 36 and here's 6. And when we actually get there, my value might be something else. My value might be 0. As long as I can see that you're approaching 36, but when you get there, your value is not 36, I would accept that as an example of the limit. You could also say that f of x is equal to, you could use a piecewise function and say x squared when x is not equal to 6, and then it's 0 or any other number when x is equal to 6. As long as we're getting near 6, or we're getting near 36, but we don't actually reach 36 when we get to that point, that would be an acceptable answer. Okay. Number 2, if f of x equals 6x squared plus 4, then what is the limit as x approaches 0 of f of x minus f of 0 all divided by 2x squared? So all this is asking you to do first is plug in the f of x, plug in f of 0, and then find the limit. So f of x is 6x squared plus 4. And then I'm going to minus f of 0. So if I plug 0 in right here, f of 0 is going to equal 6 times 0 plus 4. So that 0 is going away, and I just get a plus 4. But I have to minus that plus 4, so that becomes a minus 4 divided by 2x squared. So that simplifies to be 6x squared, because 4 minus 4 is 0, divided by 2x squared. My x squareds cancel. 6 over 2 simplifies to 3. So my limit's just 3. I don't even have to plug in zeros anywhere for x's because all my x's cancel out. Okay. Number 3, if f of x equals x squared minus 4x over root x, what's f prime of x? So you have a couple of options here. You can use the quotient rule, is one way to do this one. Whatever way that you do it, the first thing we have to do is change this root x. We've got to change this to x to the 1/2 on the bottom. Then you have options. Like I said, you can leave it x squared minus 4x divided by x to the 1/2. And you can just do the chain rule and do a lot of simplifying. You can also take this x to the 1/2 and move it to the top and make it an x to the negative 1/2. In that case, you would be doing x squared minus 4x being multiplied by x to the negative 1/2. So right here, you just have a product rule, which you know how to do the derivative of. The other option, once I move it up here to the top, because I've got a bunch of x's in here, I'm going to actually distribute this x to the negative 1/2 inside. So x to the negative 1/2 multiplied by x squared can be rewritten as I take the 2 minus 1/2, and that just becomes x to the 3/2. And then negative 4x times x to the 1/2. I still got the negative 4. And x to the 1 minus 1/2 just becomes x to the 1/2. So if I rewrite it that way, I don't have to do the quotient rule or the product rule because I already did my simplifying. So from here, if I just do f prime of x, that equals 3/2 x to the 1/2 minus 1/2 times negative 4 is going to be negative 2x to the negative 1/2. And then when I get rid of these halves, just because I might as well, I can rewrite this as 3 over 2 root x, or I could put the root x on top, minus, I'm going to leave the 2 on top, but the root x, the x to the half, the negative moves to the bottom and just becomes root x. Now, if this was a free response question, this would be an acceptable answer. If this was multiple choice, I'm guessing that they would want you to get a common denominator and just have one big fraction. So you would have to multiply this side by root x. You would have to multiply this side by 2. And I mean, let's look at what that would look like. So basically what I'm doing from here, even though this is the correct answer, I'm going to take everything on this side and multiply it by root x over root x, and everything over here, I'm going to multiply by 2. So I end up with 3 root x times root x is x over 2 root x. And then I'm going to minus 2 times 2 is 4 over 2 root x. And when I combine these into one fraction, I get 3x minus 4 over 2 root x. That would be my multiple choice answer. That's probably closer to what it would look like on a multiple choice test. Okay, I will accept this one on our test, but just know that those are the same answers. Okay, number 4, use the graph to estimate the limit as x approaches 2 of f of x. So as x approaches 2, 2 is right here. And from the left-hand side, as I approach 2, I'm coming in from the top. And from the right-hand side, I'm coming in from the bottom, and they're nowhere near each other. So I can tell you right now that the limit does not exist. They're approaching 2 completely different numbers coming from the left and the right. And that jump right there at 2 tells you that it's discontinuous, and that's going to be our limit not existing. All right. Number 5, if f of x is equal to 3x to the 4th minus 6x cubed plus 3x minus 2, what is f prime of x? So f prime of x is equal to 12. Whoops, I almost wrote 4. I've got to drop the 4 down and get 12x to the 3rd power. The 3 multiplies down to become negative 18x squared. Plus 3x becomes plus 3, and the minus 2 goes away. And that's going to be my derivative right there. That's all you have to do. Number 6, let f of x equal root 3x cubed minus 1. Calculate the inverse of f of x. So this is f inverse of x, which means this is really saying y equals root 3x cubed minus 1. So what I'm going to do is switch my x and my y, and then I'm going to solve for y. So let's give ourselves a little bit more room. I don't like erasing things as we go. We will if we need to. But if I switch my x and my y and say that x is equal to root 3y cubed minus 1, now I want to get y by itself. So I start by squaring both sides. So I get x squared equals 3y cubed minus 1. Then I'm going to add 1 to both sides. So I get x squared plus 1 equals 3y cubed. I divide by 3. So y cubed equals x squared plus 1 divided by 3. And then to get rid of the cube, I have to take the cube root of both sides. So y is going to equal the cube root of x squared plus 1 divided by 3. And instead of y, usually we'll write it the way they wanted us to, f inverse of x, the inverse of f of x. Okay, so this would be your final answer for number 6. Number 7, suppose that the position equation for a moving object is given by s of t equals 3t squared minus 2t plus 5, where s is measured in meters and t is measured in seconds. Find the velocity of the object when t is equal to 3. Well, velocity, if this is my position function, remember that the derivative of my position function is equal to my velocity function. So if I'm looking for velocity, I just have to take the derivative of my position function right here. So if I've got 3t squared minus 2t plus 5, and I want to take the derivative, I get 6t to the 1st power minus 2. The plus 5 goes away, So this would be my velocity function. And it doesn't just want any velocity. It wants my velocity when time is equal to 3. So v of 3 equals 6 times 3 minus 2, which is 18 minus 2, which is 16. And I would say that it's not just 16. It gives us, it's measured in meters and seconds. So that's 16 meters per second. Okay. All right, 8. Let f and g be functions that are differentiable everywhere. That's important. If g is the inverse function of f, and if g of 3 is equal to 8, and f prime of 8 is equal to negative 2/5, then g prime of 3 is equal to what? Wow, that's a lot of information all at once. So first thing that's important, g is the inverse of f. So obviously we're looking for an inverse. We're going to be using inverses here. So if I have my function f and my function g, I know that g of 3 is equal to 8. So that means if I plug 3 into g, I get an output of 8. And since f and g are inverses, if I plug an 8 into f, I'm going to get out a 3. So my 3, 8 over here becomes 8, 3 for my f function. And then it tells me if I take the derivative of f at 8, I get negative 2/5. So my slope is going to be negative 2/5. Now I can use that information because if my slope at 8, 3 is negative 2/5, then my slope at the inverse, instead of 8, 3, my slope at 3, 8 is the reciprocal. It's going to be negative 5/2. So g prime of 3, my slope at 3 is negative 5/2. I like the way that problem flows. It really makes sure that you understand what inverses mean and how they work, even in function notation. We have no idea what the functions are, but knowing information about the function, you should be able to work your way through that one. Okay, number 9. Find an equation for the tangent line to the graph of f of x equals the natural log of x squared minus 1 at the point where x equals 2. So find an equation for the tangent line, which means I need a slope and I need a point. And it gives me an x value, but I don't have my y value. So let's go ahead and plug the x into my function. Let's find f of 2. That's ln natural log of 2 squared minus 1, which equals the natural log of 4 minus 1, which just equals the natural log of 3. So my point that I'm going to use is 2 comma natural log 3. You are welcome to put that in your calculator, but I don't know why you would. We can natural log of 3. That's a great, nice number to use as opposed to the decimal that you're going to get when you plug it in. So now that I have my point, I just need to find the slope. And to find the slope, I need to find f prime. So f prime of x is equal to, now remember the natural log derivative is just 1 over whatever's on the inside. But if the inside is a function, then we have to times it. We have to use the chain rule. We have to times that by u prime. And so that looked like u prime over u. So basically, it's just the derivative of the inside on top and the inside on the bottom. The natural log completely goes away. So the derivative of the inside, the derivative of x squared minus 1 is just 2x. And then the inside is just x squared minus 1. So this is my slope function. This is my derivative function. And I want to know at x equals 2. So I need to find f prime of 2. So I plug in a 2 and I get 4 over 4 squared, or 2 squared, which is 4 minus 1, which is 3. So that's just 4/3. And now I can plug these into my tangent line formula. Remember, that's y minus y1 equals the slope times x minus x1. So I've got y minus my y value, natural log of 3, equals my slope, 4/3, times x minus 2, my x value. So again, if this was the free response, that would be your final answer right there. If it was multiple choice, they might add the natural log to the other side. They might distribute the 4/3 and add the natural log. There's different ways that they could simplify this. As long as you recognize that it's the same as this answer, you'll be okay. So number 10, find the derivative if y equals e to the x minus x equals y squared. So right here, we have a product rule. And not only do we have a product rule, but we're actually doing implicit differentials because we have x's and y's. So when I take the derivative of this side, the left side, I've got to use the product rule right here. So I've got y is one function and e to the x is the other. So the derivative of y is 1 dy dx. And I've got to multiply that by the e to the x. And then I'm going to add the derivative of e to the x is just e to the x multiplied by y. So that part didn't even change at all. We still just have e to the x times y. And then don't forget to take the derivative of minus x, which is going to be minus 1. And that's going to equal the derivative of y squared is 2y dy dx. Now remember, we want to get the dy dx's alone. So let's leave this over here, and I'm going to minus this piece right here to the other side. We're going to subtract that from both sides. So I'm going to subtract, and I'll put the e to the x in front, e to the x dy dx. I don't need that 1. So this I move to the other side. And now that I've got my dy dx's on one side, I can factor them out. So I'm going to end up with e to the x times y minus 1 is equal to, if I factor out that dy dx, I'm left with 2y minus e to the x, which I'm going to divide to the other side to get rid of it. So dy dx is equal to e to the x times y, minus. I wrote plus, but I started to write, or I said minus, I started to write a plus. E to the x y minus 1 divided by 2y minus e to the x. That's a great answer. There's not much more you can do to simplify that. And it doesn't look super pretty, but that's the best we're going to get with all of those e functions in there. Number 11, find f prime of x if f of x equals negative cosine squared 3x. Now this might, be careful. What this cosine squared 3x means is what it doesn't want you to do. It doesn't want you to mix it up and think that this is cosine of 3x squared. It wants you to, this is like saying you take the cosine of 3x and then you square it. That's what that 2 being right there means. So I can rewrite this, f of x equals, and I'm going to write it this way, the negative cosine of 3x squared up there, because I have to use the product rule and the chain rule. Actually, I'm going to use the chain rule inside the chain rule twice. So to take f prime, first I got to do the derivative of the outside. So I've got to drop that 2 down. That becomes negative 2 out in front. The cosine 3x stays there, cosine of 3x. And this 2 drops to a 1, so I don't even have to include it. I can just put negative 2 cosine of 3x. But now I need to multiply by the derivative of the inside. So I need to multiply by the derivative of cosine of 3x, which is just negative sine of 3x. But I can't forget that when I take the derivative of cosine 3x, I have another chain rule, the 3 on the inside. So I've got to remember to multiply by 3. So you have a power rule and then double chain rules, a chain rule inside another chain rule. So be careful there. Now when I simplify, the 3 and the negative 2 can multiply to be negative 6. And then I'm left with Actually, you know what? This negative in front of the sign, let's multiply that in as well so that we get a positive 6. And then I have cosine 3x sine 3x would be your final answer. That would be your f prime of x. Okay, number 12. We're getting kind of tight on space, so I'll try and switch colors. Differentiate y equals x squared over x squared plus 1. So we have a couple of options here. I'm going to go ahead and use the quotient rule. I know some of you are going to want to move this to the top and make it raised to the -1 and do some other things there. I'm just going to go ahead and use the quotient rule. So the derivative of the top, 2x, multiplied by the bottom, so x squared plus 1, minus the derivative of the bottom, which is 2x, multiplied by the top, which is x squared. And then all of that has to get divided by the bottom squared. That's my quotient rule. Derivative of the top times the bottom, multiply or minus the derivative of the bottom times the top, all divided by the bottom squared. So when I distribute these two x's, I'm going to end up with 2x cubed plus 2x. And then when I distribute this negative 2x, I'm going to get minus 2x cubed all over x squared plus 1 squared. So those are going to cancel out, and I'm just left with 2x over x squared plus 1 squared. And that's as simplified as it's going to get for me. Okay, 13. Find the derivative, dy dx, for 5x squared minus 2xy plus 7y squared equals 0. So here's another implicit equation. We don't want to try and get those y's by themselves, so we're going to go ahead and do the derivative implicitly. So the 5x squared, when I take the derivative of 5x squared, I get 10x minus 2 times xy. Now, I've got two variables here, so I have to treat this like two functions. So I'm going to treat the -2 as one function, or the -2x, sorry. We're going to do the -2x as one of my functions, and then we're going to treat y as the other function. So the derivative of the first, the derivative of -2x is just -2 multiplied by the second, which is just y. And then I have to add the derivative of the second. The derivative of y is just dy dx, or y prime if you like to write it that way, multiplied by -2x. And then don't forget about this over here. I've got to add 14y dy dx. And then that's going to equal 0. Okay. So we've got some simplifying to do here. First of all, I want to get the dy dx's together. But before we do that, let's rewrite this just a little bit. So I've got 10x minus 2y. And then this minus 2x, I'm going to move to the front of my dy dx just because I like it written that way better. And then I'm going to add the 14y dy dx equals 0. So I want my dy dx's together. So I'm going to go ahead and move the 10x and the minus 2y to the other side. And what that's going to look like, to move the 10x, I've got a minus 10x. And to move the minus 2y, I've got to add 2y, which makes them go away on this side. So I just have -2x dy dx plus 14y dy dx equals -10x plus 2y. Now I can factor out the dy dx. So I get dy dx, and I'm left with -2x plus 14y equals -10x plus 2y. I'm running out of space. To get rid of the parentheses that are being multiplied by dy dx, I divide by those parentheses. So I get dy dx equals the -10x plus 2y divided by -2x plus 14y. And that, on a free response, we would have been okay right here. But in fact, we would have been okay. No, I guess we would have had to get to this point. But on a multiple choice, this still isn't simplified all the way because a 2 goes into everything. So I can divide everything by 2 on this side, and that gives me negative 5x plus y over negative x plus 7y. Okay, so dy dx is equal to this. Now, depending on how things got moved around, this might be written as y minus 5x over 7y minus x. It could also be negative y plus 5x over negative 7y minus or plus x. So just be careful when you're looking at multiple choice. If it doesn't look exactly like yours, double check and see if maybe they just moved some things around. And really your answers are the same. Okay. All right, number 14. Find the derivative for y equals x squared times root 2x plus 1. So we're going to have a product rule, but before I do that, I'm going to change this to be x squared multiplied by 2x plus 1 raised to the half. So what's going to happen when I take my y prime? I've got to take the derivative of the first, which is 2x, and I got to multiply that by the second, which is 2x plus 1 to the half. Then I've got to add the derivative of the second, which is 1/2, 2x plus 1 raised to the negative half. I took the derivative of the outside, but I need to remember the chain rule. I've got to times that by the derivative of the inside, which is 2. And I've got to finish my product rule. Don't forget to times that by x squared. Okay, that's where a lot of problems are going to happen. So when I simplify this, what do I get? On this side, I get 2x, and I'm going to rewrite this as the square root of 2x plus 1. And then I'm going to add, let's see, on bottom I've got a half, or I've got a half and I've got a 2. So those are going to actually cancel each other out. And I'm going to be left with x squared on top. And then this 2x plus 1 to the negative half, I'm going to move to the bottom and put back in the root 2x plus 1. Now, I can guarantee on a free response, this would be an acceptable answer. This would be an acceptable answer. But on a multiple choice, this is not going to be one of the options. It's going to want you to find a common denominator and simplify everything so that there's only one fraction. Now, this one doesn't have a denominator, so it's like it's over 1. So what we need to do is we need to multiply this to make the denominator the same. So I've got to multiply by root 2x plus 1 over root 2x plus 1. So what that's going to look like, as I try to fit all of this in here, the root of 2x plus 1 times the root of 2x plus 1 becomes 2x plus 1. But then I still have this 2x that I'm going to go ahead and write out in front and try not to forget that it's there. And then that's over root 2x plus 1. And then I'm adding x squared over root 2x plus 1. So when I get my common denominator, we can go ahead and distribute this 2x. And that gives me 4x squared plus 2x plus x squared all over root 2x plus 1, which equals 4x squared plus x squared is 5x squared plus 2x all over root 2x plus 1. Okay, that's the answer that's going to show up on the multiple choice. And even then, no, I think they would leave the root on the bottom. If that plus 1 was on the outside, they might rationalize the denominator, but it's not. It's on the inside. So I don't imagine them multiplying the bottom by root 2x plus 1 and the top. I feel like this is probably going to be the answer that you get, or that you have to choose from. All right. Okay, so 15. We are completely out of room. So let's, as much as I don't like doing this, we're going to erase a lot of work here, and we are going to do number 15 just over here to the side. So y equals x to the 3 minus 2x, and it wants us to differentiate. So what I need to do, first of all, this 3 minus 2x up here in the exponent is an issue. We've got to bring it down. So the way that we bring that down is by either using e or the natural log. Now, since this is x raised to the 3 minus 2x, I don't want to use the e. I want to use the natural log. Because what I'm going to do, I'm going to move this up. I'm just going to work up here a little bit. I'm going to take the natural log of y. The natural log of the left-hand side is going to equal the natural log of the right-hand side. And what that lets me do is, now that I have the natural log of x raised to this exponent, I can take the exponent and move it down in front. So this becomes natural log of y equals 3 minus 2x multiplied by the natural log of x. Now I can differentiate, which is nice with natural logs because the derivatives are pretty easy. So when I take the derivative of this side, remember the derivative of the natural log of anything is equal to 1 over the inside. So the natural log of y is just 1 over y, but we're taking the differential with respect to x, so I need to remember to put dy dx. And that's going to equal, right here I've got a product rule. I've got this multiplied by natural log of x. So the derivative of the first, and let's maybe highlight this for you a little bit. The derivative of the first is negative 2. And we multiply that by the natural log of x. And then we have to add the derivative of the second. Well, the derivative of natural log of x is just 1 over x multiplied by the first, which is 3 minus 2x. So when I rewrite this, I get 1 over y dy dx is equal to negative 2 natural log of x. And then I'm going to add this 3 minus 2x can just go to the top, all over x. Now, it doesn't want 1 over y dy dx. It wants just the derivative, just the dy dx. So to get rid of this 1 over y, I'm going to multiply both sides by y, because these are going to cancel. And when I take this side and multiply it by y, I end up with dy dx equals all of this, negative 2 natural log x, plus 3 minus 2x over x, multiplied by y. And I don't want to use y because I actually know what y is from my original equation. So instead of y, I'm going to plug in x to the 3 minus 2x so that I don't have any y's in my differential. So that would be your final answer, which when I just started with x to the 3 minus 2x, that doesn't look like a very complicated problem. But by the time you're done, that's a really messy derivative that you're working through. All right. Okay, number 16. Differentiate with respect to x. Y equals e to the 5 minus 2 over x. So this is kind of similar to what we did. I'm going to take the derivative of both sides. So when I take the derivative of the left, that's just dy dx. And that equals the derivative of e to a function. Remember, is just e to the x, but you have to multiply by the derivative of whatever's on the inside up there. So this becomes e to the 5 minus 2 over x. But I've got to multiply by the derivative of this part right here. I've got to multiply by the derivative of the inside right there, that chain rule. So that looks like 5 minus 2 over x, which is really just 5 minus 2 times x to the negative 1. So when I take the derivative, this is x to the 1, I made it a negative by moving it up. So to take the derivative, the 5 goes away. The negative 1 multiplies down. So negative 1 times negative 2 is positive 2. And then I get x, and this negative 1 drops down to negative 2. So right here, I get a 2x to the negative 2 And I want to rewrite that as e to the 5 minus 2 over x. The 2, I'm going to go ahead and move out in front. And the x to the negative 2, I'm going to move to the bottom. So what that looks like, now that it's written all kind of messy, dy dx equals 2e to the 5 minus 2 over x divided by x squared would be your final answer, okay? All right, 17. If the position of a particle on the x-axis at time t is f of t equals 1/4 t squared plus 6, what is the average velocity of the particle for the interval 0 to 10? So it gives us a time function, a position function with our measured in time. Now it's asking for average velocity. If this was asking for the instantaneous velocity, we would take the derivative. We would take f prime of t. But it doesn't want instantaneous velocity. It wants average velocity. So all we're going to do is our y minus y1, or I guess we better do y2 minus y1 over x2 minus x1. We just use our original slope formula. So the 2 points that I'm interested in are 0 and 10, but I don't know the y values that go with 0 and 10. So I have to plug those into my function and get my y values. So f of 0 is going to equal 1/4 times 0 squared plus 6. So that's going to cancel, and I'm just going to end up with 6. So one of my points is 0, comma 6. My other point, I'm going to plug in 10. So f of 10, because that's my interval that I'm looking between. So that's 1/4 10 squared plus 6, which equals 1/4 times 100 plus 6, which equals 25 plus 6, which equals 31. So my second point is 10, comma 31. Now I plug these 2 points into my slope formula. So let's call this, this will be our second point, and this can be our first point, okay? So we're going to say 31 minus 6 over 10 minus 0 is 25 over 10, which is either 5/2 or what, 2.5? Either of those works for me. And it didn't give us units, so we don't know if that's meters per second or feet per hour. We don't have any sort of measurement of time. So we're just going to use 5/2 or 2.5. No units for that one. Okay, number 18, find an equation of the tangent line to the graph of x squared plus 3y squared equals 4 at the point 1, 1. So I'm looking for the equation of a tangent line, which means I need a point and I need a slope. I've already got my point. That's nice. So I just need to find the slope using this formula. So I'm going to take the derivative of the formula that it gave me. So the derivative of x squared is 2x. The derivative of 3y squared is 6y dy dx, because we're doing implicit differentiation. There's a lot of that on this test. Hopefully you guys are getting better at it. And that's equal to the derivative of 4, which is just 0. So now I'm trying to get, well, I guess at this point I have a few options. I'm trying to get dy dx by itself. But I know that my x and my y are 1 and 1. So I can either plug those in right now, or I can get dy dx by itself and then plug in the 1 and the 1. While I'm already working with the equation, I'm just going to keep going. I'm going to minus 2x from both sides so that I get 6y dy dx equals negative 2x. And then to get rid of the 6y, I'm going to divide by 6y. And that's going to become, so my dy dx is going to equal negative 2 over 6 is just negative 1/3. And I've got x over y. So negative x over 3y. So now if I plug in the 1 and the 1, this just becomes negative 1 times 1 on top and 3 times 1 on the bottom, which is just negative 1/3. So that's going to be my slope that I want to use. So I've got all the information I need. I just plug it into my point slope formula. So y minus 1 is equal to my slope, negative 1/3, times x minus 1. Again, free response, that's a great answer. Multiple choice, they might add the 1 to both sides. They might distribute that negative 1/3 and then add the 1. Just be careful that you can recognize that it's the same thing. But on our test, this would be an acceptable answer for me. So 19, if the line 4x minus 2y is equal to 0, if that line is tangent in the first quadrant to the curve y equals x squared plus k, then what is k? Okay, that's a lot of information. So what's happening is I have, in my first quadrant, I have some sort of parabola. And I've got a line that is tangent to that parabola at a certain point. And I'm trying to figure out what that point is so that I can figure out what k is, which there's some roundabout work here. Starting with what I know. All I know is the formula for the straight line and most of the formula for the curve, but I'm looking for that k piece. What I know is if these two are tangent to each other at this point, what that means is at that point, the slopes are equal to each other. If they're tangent right there, that means that their slopes at that point are exactly the same slope. So what I want to do, I'm going to start by working with my formula here on the left because we've got to get our slope formula. So I'm going to take the derivative of this left-hand side, which is 4 minus 2 dy dx equals 0. And then I got to get the dy dx by itself. So I'm going to minus 4 from both sides, make that go away, and then I'm going to divide by negative 2. So I end up with dy dx equals negative 4 divided by negative 2 is just 2. So the slope of my straight line at this point, my slope is going to be 2. So if I come over to this curve and I take the derivative of my parabola, so the derivative dy dx equals 2x, and I don't know what k is, but it doesn't matter because when I take the derivative, k goes away. So I'm just left dy dx equals 2x. Now, at this point, wherever this point is, my slopes are going to be the same. So I need this slope right here. What x value is going to make it equal to 2? What's going to make my slopes the same? So to make this equal to 2, that means that x has to equal 1. For my slope right here to be 2, x has to equal 1. So that tells me that this x value right here is 1. Because at x equals 1, my slopes are the same. I need a little bit more information. That gives me my x value, but I really need my y value also. So what I can do is I can come back to my original equation and I can find my y value by plugging in x. So if I plug in x equals 1, I get 4 times 1 minus 2y equals 0. So negative 2y equals negative 4. So y equals 1, or not 1, y equals 2. Because when I divide by negative 2, I'm going to get 2. So that means that the point that these are equal to each other is at 1, 2. So my point is 1, 2. Which still doesn't get me what I need, but it does give me my y value and my x value for this function. I know that my y is going to be 2 and my x is going to be 1. Now I can figure out what the k is, because 2 equals 1 squared plus k. So 2 equals 1 plus k. So when I minus 1 from both sides, k is equal to 1. So that right there, that is an absolute AP question because it's asking you to connect a lot of dots. It's asking you to recognize that for the tangent, for those two equations to be tangent to each other, that means their slopes are the same at that point. And then from there, there's a lot of problem solving. You have to find the slope of 1, plug that value in to figure out what x is, plug that in to figure out what y is, plug those in to figure out what k is. There's a lot of back and forth on this problem. That's a good one to practice a couple of times for the test and keep in mind going forward with AP stuff. All right, number 20. Find dy dx, then evaluate the derivative at the point 0, 2, and it gives me another implicit function. So it really wants us to practice these functions this way. So I'm going to take the derivative of this right here. And it looks a lot like what we did earlier. This looks a lot like, I think it was on the last page. It's going to look a lot, where did it go? Where did it go? Where did it go? This one right here, number 13. In fact, it's really, really similar to number 13. Close enough that, well, we'll do it anyway. Okay, so I'm going to take the derivative of the left. So the derivative of x squared is 2x. The derivative of negative 2xy squared, this is where we've got to use the product rule, because there's one function, negative 2x, and my other function is the y squared. So the derivative of the first, the derivative of negative 2x is just negative 2, multiplied by the derivative, or the second function, the y squared. And then I've got to add the derivative of the second, which is 2y dy dx, multiplied by the first, which is negative 2. And that's going to equal the derivative of y cubed is 3y squared dy dx. And the derivative of minus 8 is nothing. So I've got a pretty messy equation right here. Let's clean it up just a little bit. This is 2x. This is negative 2y squared. This negative 2 can move to the front and become minus 4y dy dx. And that's going to equal 3y squared dy dx. Now, it wants me to find dy dx. I'm not there yet. I've got to get dy dx by itself. But it gives me a little bit of information that can maybe help make this a little bit easier. I don't need just the general dy dx. Oh, maybe I do. It tells me to find it and then evaluate. One option I have, I can plug in the 0 and the 2, and I can find the derivative at this point. But what makes me nervous about that is it wants me to find the derivative first. It doesn't say find the derivative at this point. It says find the derivative, then evaluate it. So if this was like an AP question, I would expect this to be one part and this to be another. So if I plug in the 0 and the 2 right now, I'm skipping this part in a roundabout way, and I might not get full credit. So let's go ahead, and even though it's going to be messy, let's go ahead and solve this for dy dx with the x's and the y's and all that other messy junk in there. So what I'm going to do is I'm going to move this minus 4y dy dx. I'm going to move that to the other side by adding 4y dy dx. So I end up with, I'm left over on the left-hand side, I've got 2x minus 2y squared, and that's going to equal 3y squared dy dx. I know there's some of you that are just so annoyed that I'm not writing y primed right now, and I'm okay with that. Plus that 4y dy dx. I'm not going to mix it up with y to the first power. Now I've got to factor out this dy dx. So I get 2x minus 2y squared equals dy dx. I'm going to factor it out, and I'm left with 3y squared plus 4y. Now I can divide this to the other side. So I get dy dx equals 2x minus 2y squared divided by 3y squared plus 4y. I feel like I'm missing an X somewhere, but I think we're okay. I think we're okay. So at this point, I am going to plug, now that I know what my derivative is, I'm going to go ahead and plug in my 0 and my 2. So I end up with dy dx is equal to 2 times 0 minus 2 times 2 squared divided by 3 times 2 squared plus 4 times 2. So that's going to equal, this goes to 0. 2 squared is 4 times negative 2 is negative 8. 2 squared is 4 times 3 is 12. Plus 4 times 2 is 8. And I get negative 8 over 20, which is negative 2/5. See, I feel like my 4 times 2 should have gone away somewhere. Did I write a x where I should have written a y? 2x minus 2y squared. And then I had 2y times, nope, I'm okay with that. Negative 2/5. I think that's a good answer. I felt like right here, no, where'd it go? I felt like this y right here might need to be an x, but I got that y right here when I took the derivative of my y squared, my second function. So there should be a y there, not an x. So this is a great answer. 21. All right, let's get back on track. I'm glad that you could sit there and stumble through my thoughts with me. See what happens when you don't do all the problems ahead of time? You get to think through, hoping that you catch any little mistakes that you might have made. Okay, let f and g be differentiable functions such that f of 2 equals 4, g of 2 equals 3, f prime of 3 is negative 1, blah, blah, blah. It gives us basically a table with a bunch of values. Then it says if h of x equals f of g of x, then what is h prime of 2? So we practice these on homework 2.3 with our table questions. Before I can find h prime of 2, I've got to find h prime of x, which means I've got to take the derivative of this right here. So to do that, I take the derivative of the outside and I leave the inside the same. So the derivative of f prime, but I leave the inside the same. But the chain rule tells me I have to multiply by the derivative of the inside. So this is just a chain rule problem. The derivative of the outside, keep them inside the same, multiplied by the derivative of the inside. So there's my h prime, but it wants me to find h prime of 2. So that everywhere there's an x, I'm just going to replace it. So I get f prime of g of 2 multiplied by g prime of 2. So g of 2, if I go up to my table, g of 2 is equal to 3. So this becomes f prime of 3 multiplied by g prime of 2. F prime of 3 is right here. That's negative 1 multiplied by g prime of 2, which is right there. That's 3. And I get negative 3. So h prime of 2 is just negative 3. Okay, 22. If the limit as x goes to negative 3 of f of x equals 4, what do we know for sure about f of x? And draw some possible graphs for f of x. So as we approach negative 3, our function approaches 4. So what do I know for sure? Well, that's about it. As x approaches negative 3 from the left and right, then y approaches 4. I don't know what happens at negative 3. So my function here, as I get close to negative 3 is right here. I'm getting close to 4. But at negative 3, I don't know what happens. I don't know if I reach 4. I don't know if this is just a straight line that goes left and right. I don't know if this might be some sort of, I still might have an open circle here. I don't know this value. I just know that as I'm coming from the left, I'm getting near it. And as I'm coming from the right, I'm also getting near it. That's all I know for sure. I don't know if it's continuous. I don't know if it's differentiable. All I know is that I'm getting close to that point. Okay. All right. 23. Find all the points on the graph of f of x equals x cubed minus 3x where there is a horizontal tangent line. Okay, so horizontal tangent line. Remember that a horizontal tangent line means that the slope is equal to 0 because my tangent line is going straight left and right. It's not climbing at all. So my slope is 0. So what I've got to do is set this, I've got to find my slope function and set it equal to 0. So f prime of x equals, this drops down to become 3x squared. The negative 3x just becomes negative 3 when I take the derivative. And I want to know, when does this function equal 0? When is my slope 0? So I'm going to set that 3x squared minus 3. I'm going to set that equal to 0. So I'm going to add 3 to both sides. So 3x squared equals 3. I'm going to go ahead and divide by 3. So x squared equals 1 because I divided by 3. When I take the square root, here's where we need to be careful. When I take the square root of 1, I get a positive 1, but I also get a negative 1. And that's why it says find all the points, because there could be more than one. So I know my x values. I don't know my points yet because I've got to plug my x values back into my function. So f of 1 is 1 cubed minus 3 times 1, which is just 1 minus 3, which is negative 2. So one of my points is 1 comma negative 2. That's one of them. The other point, I've got to plug in negative 1. So I get negative 1 cubed minus 3 times negative 1. Negative 1 cubed is negative 1, and this is going to become a plus 3, so my value is going to be positive 2. So my other point is at negative 1 comma 2. So those would be my 2 points where my tangent line is horizontal. So what that means is at those points, at 1, negative 2, so here's 1, negative 2, at this point and at negative 1, positive 2, at that point, I know that my graph is changing concavity, right? Right here, it's concave up, and then all of a sudden it might be concave down, and then it's going to do the same thing. Or it might be a max or a min. There could be a couple of different things that are turning that into a horizontal tangent line. Okay, 24. I like this one a lot. I'm glad we were able to fit it in on the test. I mean the review, because this isn't the test. This is the review. A coin is dropped from a height of 900 feet. The height is measured in feet, and the time is measured in seconds. But the height is given by this function. S of t equals negative 16t squared plus 900. Find the average velocity on the interval 1, 4. So between 1 second and 4 seconds, what is the average speed of this coin? I'm not using the derivative because it wants the average velocity. So I'm just going to use my y2 minus y1 over x2 minus x1. I'm just using my normal slope formula when I have 2 points. So I need to plug in a 1 and I need to plug in a 4 and see what I get. So S of 1 is equal to negative 16 times 1 squared plus 900. That's a plus. And then S of 4 is equal to negative 16 times 4 squared plus 900. So this one is going to come out to be, what, 884. And this one comes out to be 644. So those are my average velocity. Those are my points, 1, 884 and 4, 644. So I need to fill out this formula to get my average velocity. So I'm going to take 884 minus 644 over 1 minus 4. So this is going to equal 240. This is going to equal negative 3. So that becomes negative 80 is my velocity, not my speed. My speed is 80. My velocity, which I'm looking for, is negative 80, and it gives me units, feet per second. Or you could write it negative 80 feet per second. Either way, same thing. Find the instantaneous velocity when t is equal to 4. So instantaneous velocity is that slope of my tangent line. So this one, we do want to take the derivative. So the derivative of s is going to be, drop the 2 down, that's negative 32 times t. The 900 goes away. So this is my derivative formula right here. And now I just plug in the 4. So s prime of 4 equals negative 32 times 4, which is negative 128 feet per second. Okay. So at 4 seconds, I'm going, or my coin is going negative 128 feet per second. How long does it take for the coin to hit the ground? Well, I don't know the time. That's what I'm looking for. I'm looking for time. But when it hits the ground, my height is going to be 0, which means s of t is going to be 0. So I just have to take my original function and set it equal to 0. So negative 16 t squared plus 900 equals 0. We're going to minus 900 from both sides. So I get negative 16 t squared equals negative 900. Divide by negative 16. T squared equals negative 900 over negative 16. So those negatives cancel, and I take the square root. Oops, I forgot a 0 there. I don't know what that is in my head. So let's do second square root 900 divided by 16. And I get 7.5. Now, technically, I've got 7.5 and negative 7.5. But when I'm dealing with time, we ignore the negative time. At least in this case, we do. So my answer would be 7.5 seconds is how long it takes to hit the ground. That's when my height is 0. Then it wants me to find the velocity of the coin when it hits the ground. So I need to use my velocity formula, my slope formula, and I'm going to plug in the time it takes to hit the ground. That's 7.5. So I'm looking for s prime of 7.5, which equals negative 32 multiplied by 7.5, which, I don't know, 7.5 times negative 32 is going to give me negative 240 feet per second. Okay, it does. If it asked for my speed, I would say, or the coin speed, I would say 240 feet per second. The negative tells us that it is going down at that speed.